This is the Commodore VIC-20, the first personal computer we had when I was a teenager. It was released around 1981. It had colors, sound, and very low resolution graphics, but it had only 4K of RAM. Still, I learned a lot from it, including the 6502 CPU assembly language, but also playing the most impossible games. This one is the father of all personal computers, the Commodore PET. I remember it in the shop when we bought our VIC-20. The original PET was released in 1977. This one is the second generation PET, the PET 8032. The PET 8032 was a very impressive machine for its time. It had 32K of RAM, 80 columns display, a professional keyboard, and a nice integrated 12-inch green monitor. Unfortunately, the Commodore PET was lacking colors and had only text capabilities. I never owned a PET, till 6 months ago when I could find this machine for a reasonable price. It was in a very good shape, but unfortunately was not working. It took me some time to fix the issues, but I learned a lot during the repair process. I really love this machine, but I really lack colors and graphics, so I decided to add them. Which brings us to the context of this project. 40 years later, this great machine deserves a modern extension board, the HyperPET Pico. The HyperPET Pico is a kind of extension for the PET, which is using the Raspberry Pi Pico like many other projects are doing today. The initial idea of the HyperPET Pico was to offer VGA output to the PET 4032 or 8032. So the Raspberry Pico is actually spying the memory bus and reproduce actually the video image which is on the PET. It just tried to reproduce that on the VGA output of the Raspberry Pico by just reproducing the graphics, in this case the characters, etc. So initially that was the idea, and both 40 and 80 colors were supported. But it turned out that the Raspberry Pico was strong enough to add graphics feature. So I first added colors, up to 256 colors in RGB 332. And one first application was to add background layer, being plain colors, or raster colors, or even a 320 by 200 color bitmap. Then I added two independent tile layers, a bit like on the NES, with smooth scrolling capabilities in all directions. Then I added sprite capabilities, 16 sprites that could be reused up to 96, and finally sound capabilities using the SID emulation of the Commodore 64. When you connect the HyperPET Pico module to the real PET, the module is only used for the extended graphics capabilities. So when you run a program, you will see at certain time the PET screen will not display the same as the VGA output, because only the new features are available on the new display. Let's give it a try. You can actually browse the files of the PET using, for example, a disk drive or a tape. In my case, I use a PET disk mask, which is connected to the IEEE port of the PET. So first application is to put a background image. So the background image is displayed below the text layer. in such a way that you can actually continue typing and keep that background layer. You can also browse the files using actually the storage of the Raspberry Pico. In fact, there is on the Pico 2 megabytes of RAM, 1 megabyte is used for the program, and the other megabyte is used for storing all kinds of files. And you can access the file browser by using a sys command, and then it will show you a menu where you can actually load files. Let's continue the demo. After the bitmap, you can start adding sprites. You can see up to 96 sprites. There is always maximum 16 sprites per row, but you can reuse these 16 sprites a bit like on the Commodore 64. Let's go a bit further. Let's try to animate these sprites. In fact, the sprites are sorted in the Y order in such a way that it's easy to reuse them. You don't normally have to care about how many are used per line. As soon as there are more than 16 that are displayed on one line, there will be some flickering, but in most of the time the system will take care that they are spread over the Y-axis. Then you can start displaying tiles. First demo will show an horizontal scrolling using a single tile layer. In fact, I didn't mention it, but the resolution supported are in fact 80 columns, which is 640 by 200, 40 columns, which is 320 by 200, but also a new graphical mode, which is actually 256 by 200. And 256 pixels, why? Because then every coordinates will fit on a 1 octet, 1 byte, which will help the processing if you create a game. Then we can go further. We can use the 2 tiles layers and use the high resolution. In this case, what we have is a dual layer scrolling using the 2 tiles layers, this time in 80 columns mode, so in 640 by 480. On top of that you have the reusable sprites, and in background you can also have a plain color, but also actually raster colors, as we called it at the time of the Commodore 64. So the tiles supported can be 16 by 16 pixels or 8 by 8 pixels. In this case it is 8 by 8 pixels. The demo is actually the background of the NES Mario game, which is just displayed on this HyperPET Pico. Then we can of course have sound. You have basic SID capability, which already allow nice sounds compared to what the original PET was able to do. The player is actually an open source routine that was ported to the 6502 because actually the C64 was 6510, but at least this routine does not fully support the SID capabilities, but at least it's just to illustrate the sound and what is possible. So that's it. As soon as you reset the PET, of course the VGA display is going to be reset as well. A last feature that is possible, at the end you will know the sys command to type. In fact, when I type this command, it's executing a program, this file browser, which is located in A000. Why? Because the HyperPET Pico, in addition to simulating this new graphics mode and sound, it's also able to emulate actually some EEPROMs regions. And one of the regions is the region A000 to AFFFF, where I can store a program. So another logical possibility is actually to plug in a different ROM than the ROM of the file browser. So it was common on the PET to add an additional EEPROM with some extra features or existing program or just extensions. For example, basic extension. You can normally install that ROM then you know, of course, you need to know the sys command, but then you have, for example, Import Basic. So you can replace the file browser by another program. But as soon as you will reset it, it will be back. So the idea again, provide an extension to the PET, which will display graphics and sound through a module which you connect externally on the device, and everything will be displayed on the VGA output. Now, if I switch off the PET, I can actually remove the module. So the module is located on the side. I can switch off the module, it's powered by USB. I can remove it. It's actually connected via one connector on another board, which is fitting on the memory box expansion. And the idea is that you can also use this module as standalone. I will show it after. But first, let me show you inside the Commodore PET. So the HyperPET Pico consists of two boards. One board which is inside the PET that you install on the memory bus expansion. And that board will offer actually on the side a new connector through which you will connect the module which is there. And then of course you connect your VGA and your sound cable at the outside. So you can see that actually there are two sockets on the PET board which are free. So this is typically the EEPROMs that were located at A00 and 900. 900, this range is actually used for all the new registers offered by the HyperPET Pico, and A00 is for the file browser. So you can actually simulate the presence of one of these EEPROM using the Raspberry Pico itself. There is also an additional wire, as you can see. This is because normally the memory expansion bus, all the cards that were connected to that, you could only read from the range 9000 to 9FFF. There was no way to read another range, so I needed a small modification, and that's just basically a single resistor that has to be lift up a little bit, and you connect this wire at the place of it. So that's an easy change, and that will allow you to actually simulate all the address range, then you can actually read it, so like simulating an EEPROM. Another feature which is also available is the possibility to, because this machine is actually a PAL machine, and the VGA display is 60 Hz, this one is 50 Hz. So there is a possibility to replace the edit ROM, which is the one with the range sticker over there. You can simulate that ROM by a 60 Hz ROM, and then you can actually display on a PAL machine. You can display 60 Hz and have 60 Hz display. So that's another possibility, and for that you need these extra wires, otherwise you won't be able to actually read from a range which is outside 9000. Voilà, that's it. So the module can be used standalone, and I will show that in another video.